The widely accepted Newtonian model of reality, based on the principle of separation, posits that humans exist in a physical world governed by laws like gravity and thermodynamics. According to this model, the universe operates independently of us. However, the advent of quantum physics has challenged this notion, suggesting a more interconnected reality. This shift, while revolutionary in science, aligns with ancient spiritual teachings. For instance, Hermes Trismegistus taught, "As above, so below," implying that the universe mirrors the consciousness projected onto it, similar to the concept of a holographic or light matrix. Quantum physics proposes that reality might not be independent at all. Observers, or human consciousness, could shape reality. This idea aligns with the concept of the multiverse and infinite timelines, as explored in modern science and theorized by thinkers like Neville Goddard. In his book, Thinking Fourth Dimensionally, Goddard suggested that the fourth dimension contains all possible life outcomes. Similarly, Dr. Joe Dispenza speaks of an infinite field of possibility in quantum physics, encompassing all potential life experiences. Key quantum physics facts supporting this perspective. The observer effect. One of the most profound discoveries in quantum mechanics is the observer effect. Experiments like the double-slit experiment show that particles such as electrons behave differently when they're being observed. When not observed, particles act as waves and display interference patterns. However, when observed, they collapse into particles, suggesting that the act of observation influences the outcome. Quantum entanglement. This phenomenon occurs when pairs or groups of particles interact in such a way that the quantum state of each particle cannot be described independently of the others, even when the particles are separated by large distances. Albert Einstein famously referred to this as spooky action at a distance. Entanglement implies that the state of one particle instantly influences the state of another, no matter the distance, indicating a deep level of interconnectedness. Wave-particle duality. Quantum objects exhibit both wave-like and particle-like properties. The behavior of quantum objects depends on how they are measured. This duality challenges classical notions of distinct particles and waves, suggesting that reality is far more fluid and interconnected than previously thought. Heisenberg's uncertainty principle. This principle states that the position and momentum of a quantum particle cannot both be precisely measured at the same time. The more accurately one property is measured, the less accurately the other can be known. This uncertainty is not due to measurement flaws, but inherent in the nature of quantum systems, highlighting the limits of our knowledge and the influence of observation. Quantum superposition. This principle holds that a quantum system can exist in multiple states simultaneously until it is observed or measured. Schrödinger's cat thought experiment illustrates this idea, where a cat in a sealed box can be both alive and dead until the box is opened and observed. This concept suggests that multiple potential realities exist concurrently, and the act of observation collapses these possibilities into a single reality. Quantum tunneling. Quantum tunneling is the phenomenon where particles can pass through energy barriers that they theoretically shouldn't be able to, according to classical physics. This occurs due to the wave-like properties of particles, allowing them to tunnel through barriers. This challenges our understanding of how particles interact with their environment and suggests that reality is influenced by probabilities rather than deterministic laws. Quantum decoherence. This theory explains how classical properties emerge from the quantum world. As quantum systems interact with their environment, they lose their quantum coherence and appear to transition into classical states. Decoherence provides insight into the boundary between the quantum and classical worlds, suggesting that our macroscopic reality is a result of underlying quantum processes. Holographic principle. Proposed in theoretical physics, the holographic principle suggests that all the information contained within a volume of space can be represented as encoded information on the boundary of that space. This idea aligns with the concept of the universe as a hologram, where the three-dimensional reality we experience might be a projection of information encoded on a two-dimensional surface. Bridging quantum physics and human experience. These quantum phenomena collectively challenge the Newtonian view of an objective, separate reality. Instead, they suggest a deeply interconnected universe where consciousness plays a critical role. If the universe operates like a hologram, then our thoughts, feelings, and state of being can shape the reality we experience. Dr. Joe Dispenza's work emphasizes that our consciousness interacts with the quantum field of infinite possibilities. By aligning our thoughts and emotions with the outcomes we desire, we can influence which potential realities materialize in our lives. This concept aligns with Neville Goddard's teachings on the power of imagination and assumption in creating our experiences. To illustrate, consider the double-slit experiment. When not observed, particles act as waves and create an interference pattern, but when observed, they behave as particles. This demonstrates that the act of observation, consciousness, directly impacts the physical manifestation of particles. Similarly, in our lives, our conscious focus and beliefs can influence the outcomes we experience. Practical implications. Understanding the interplay between consciousness and the quantum field offers practical insights. Mindfulness and intention. By cultivating mindfulness and setting clear intentions, we can align our consciousness with desired outcomes. This practice can help us manifest positive changes in our lives. Emotional regulation. Managing our emotional state is crucial. Positive emotions like gratitude and love resonate at higher frequencies, potentially attracting corresponding experiences. Visualization and affirmations. Visualizing desired outcomes and affirming positive beliefs can help reinforce the reality we wish to create, leveraging the principles of quantum physics. In summary, the evolving understanding of quantum physics supports the idea that the universe is not a separate entity, but a dynamic field influenced by consciousness. As we embrace this perspective, we realize the profound impact our thoughts, feelings, and beliefs have on shaping our reality. By consciously directing our focus, we can co-create a life that reflects our highest aspirations, aligning with the infinite possibilities inherent in the quantum field.